Dear students, welcome. This is our fourth class on vector calculus. Today we shall discuss about the divergence of a vector point function, curl of a vector point function. We shall define the divergence of a vector function and curl of a vector function, and we shall try to solve some problems on divergence of a vector function and curl of a vector function. Let us start. Divergence of a vector functions. Vector point function. Vector function or vector point function. Divergence of a vector point function. Let V vector be a differentiable vector point function or vector function. Then the divergence of V vector, which is written as div V vector. This means, and we read it as divergence of V vector, or nabla dot V vector. Nabla dot V vector means the divergence of V vector, and is defined as written as and is defined as divergence of V vector. This is equal to the divergence of V vector. This is equal to I cap delta delta x plus j cap del del y plus k cap del del z dot V vector, dot V vector. This is equal to I cap dot delta V vector by delta x plus j cap dot delta V vector by delta x, delta y. I am sorry, delta y. Plus k cap dot delta V vector by delta z. Simply you may write it as I cap dot delta V vector by delta x. You see here, this is the dot product of two functions. It will be a scalar quantity. Therefore, divergence of a vector function is a scalar quantity. Divergence, it should be noted there. You may write like that. It should be noted there. There, divergence of a vector function is a scalar quantity. Scalar quantity. Thus, the divergence of a vector point function is a scalar point function. Thus, the divergence of a vector point function, divergence of a vector point function is a scalar point function. Thus, the divergence of a vector point function is a scalar point function. Divergence of V, this it is written as nabla dot V vector. This is equal to this. This is the definition of divergence of a vector point function. Now I am going to give you a theorem regarding this. What is this? Theorem. If V vector, this is equal to V1 I cap plus V2 j cap plus V3 k cap, be a differentiable vector point function. Vector point function or vector function? Point function. Differentiable. Then the divergence of V vector or divergence of V vector equal to delta V1 by delta x plus delta V2 by delta y plus delta V3 by delta z. delta V3 by delta Z. You will get this one. If V vector equal to V1 I cap plus V2 J cap plus V3 K cap, then V3 K cap, then divergence of the vector function will be equal to this. Now, divergence of V vector equal to I cap dot delta V vector by delta X plus J cap dot delta V vector by delta Y plus K cap dot delta V vector by delta Z. By definition of a divergence of a vector function, you will get this one. Now, V vector equal to V1 I cap plus V2 J cap plus V3 K cap. This means delta V vector by delta X equal to delta V1 by delta X I cap plus delta V2 by delta X J cap plus delta V3 by delta Z delta X K cap. Therefore, I cap dot delta V vector by delta X will be equal to I cap dot delta V1 by delta X I cap plus delta V2 by delta X J cap plus delta V3 by delta X K cap. You will get this. You will get this one. This is equal to, you may write like this, delta V1 by delta X I cap dot I cap plus delta V2 by delta X I cap dot J cap plus delta V3 by delta X I cap dot K cap. You will get this one. First of all, we have applied the distributive law of dot product. Distributive law of dot product. Then we have applied this one, A vector dot MB vector equal to M A vector dot B vector. M scalar. M is scalar. A and B are vectors. M dot A. This is equal to simply delta V1 by delta X. Since I cap dot I cap equal to 1, I cap dot J cap equal to 0, I cap dot K cap equal to also 0. Therefore, I cap dot delta V by delta X, this vector is equal to delta V1 by delta X. Delta V1 by delta X, this one. Now, J cap dot. Delta V by delta Y equal to J cap dot delta V1 by delta Y I cap plus delta V1 V2 by delta Y J cap plus delta V3 by delta Y K cap. Similarly, you will get this one, delta V2 by delta Y. Since J cap dot I cap equal to 0 equal to J cap dot K cap. Also, J cap dot J cap, this is equal to 1. Therefore, you will get this. Similarly, in this way, K cap dot delta V vector by delta Z, you will get delta V3 by delta Z. Now, suppose it is number 1. It is number 1. From 1 we will get, we get. Therefore, from 1 we get means 1 implies divergence of V vector. This is equal to I cap dot this one, you will get delta V1 by delta X plus delta V2 by delta Y plus delta V3 by delta Z. V3 by delta Z, where V vector is equal to V1 I cap plus V2 J cap plus V3 K cap. You will get this one. Proved. We have proved this. Now, solenoidal vector. A vector V vector is said to be solenoidal. Vector if divergence of V vector equal to 0. If you are asked to show that a vector is solenoidal, then you should show divergence of V vector equal to 0. If it is 0, then the vector is solenoidal. Now, curl of a vector function. I am going to define the curl of a vector point function. Remember that curl of a vector point function is always a vector point function. Three things. Gradient of a scalar function is a vector function. Divergence of a vector function is a scalar function. Curl of a vector function is also always a vector function. Let f vector be a differentiable vector function. Then curl of f vector denoted by curl of f vector or nabla cross f vector or it is also called the rotational vector, rotation of f vector. F vector, comma, you should put here a comma, denoted by is defined as curl of f vector. This is equal to I cap, this is equal to this nabla cross f vector equal to I cap delta delta x plus j cap delta delta y plus k cap delta delta z cross product f vector. This is equal to I cap cross delta f vector by delta x plus j cap cross delta f vector by delta y plus k cap cross delta f vector by delta z. And simply we may write it as summation of I cap cross delta f vector by delta x. It means that summation of this means this. It should be noted that the curl of a vector function is a vector function. It should be noted that the curl of a vector function is a vector quantity. Vector quantity. Therefore, curl of a vector point function is a vector point function. Curl of a vector point function is a vector point function. It should be noted that curl of a vector function is a vector quantity. Curl of a vector point function is always a vector point function. Just divergence, I am going to give you a theorem on curl. It is called a rotational vector. Obviously, a vector f vector is an irrotational vector if curl f bar equal to 0. Curl f bar equal to 0. Then it will be called an irrotational vector theory. If f vector equal to f1 I cap plus f2 j cap plus f3 k cap be a differentiable vector function. A differentiable vector function, then if a vector is equal to this be a differentiable vector function, then is a differentiable vector function, then curl of f vector will be equal to f3 f2 I cap plus f1 f3 j cap plus f2 f1 k cap. You see, if f vector equal to this, a differentiable f1 I cap plus f2 j cap plus f3 k cap, then curl of f vector will be equal to this. Will be equal to this. Curl of f vector equal to this. Now see, curl of f vector should be equal to nabla cross f vector. This is equal to I cap del del x, j cap del del y plus k cap del del z cross f vector. This is equal to I cap cross delta f vector by delta x plus j cap cross delta f vector by delta y plus k cap cross delta f vector by delta z. This is equal to I cap cross del del x of f1 I cap plus f2 j cap plus f3 k cap plus j cap cross delta delta y of f1 I cap plus f2 j cap plus f3 k cap plus k cap cross delta delta z of f1 I cap plus f2 j cap plus f3 k cap. F3 k cap. This is equal to delta f1 by delta x I cap cross I cap plus delta f2 by delta x I cap cross j cap plus delta f3 by delta x I cap cross k cap plus from this delta f1 by delta y j cap cross I cap, you will get like this plus actually I am skipping one step. In the next step you should write delta f1 by delta x I cap plus delta f2 by delta x j cap plus delta f3 by delta x k cap plus delta f3 by delta y, you know, j cap cross I cap, j cap cross k cap plus this one delta f1 by delta z k cap cross I cap plus delta f1 f2 by delta z k cap cross j cap plus delta f3 by delta z k cap cross k cap. You will get like this. Since you may write here, since number 1, del x of f1 I cap plus f2 j cap plus f3 k cap, this is equal to delta f1 by delta x I cap plus delta f2 by delta x j cap plus delta f3 by delta x k cap. Delta f3 by delta x k cap, etc. Number 1. Number 2, we have applied what? After this we have applied A cross, and A cross MB vector equal to M A cross B vector. In vector algebra we have applied this. A vector cross MB vector equal to M A cross B vector. A cross B vector. We have applied this one. Now, I am writing here. Now, I cap cross I cap equal to 0. From this is equal to 0. I cap cross j cap k cap. This is equal to delta f2 by delta x. Delta f2 by delta x, it will be k cap plus delta f3 by delta x, it will be minus j cap. You may write here minus j cap. We have written this one. After this, j cap cross I cap equal to minus k cap minus delta f1 by delta y k cap. It will be 0. It will be j cap cross k cap equal to I cap plus delta f3 by delta y I cap after that this one plus delta f1 by delta z j cap minus delta f2 by delta z I cap. It will be 0. Since I cap cross I cap equal to j cap cross j cap equal to k cap cross k cap equal to 0 vector. Number 1. I cap cross j cap equal to k cap, j cap cross k cap equal to I cap. Also j cap cross I cap equal to minus k cap, etc. In class 12 level we have already obtained such type of formula. We have applied this one. Now I cap, combine I cap. Delta f3 by delta y minus delta f2 by delta z. I cap plus, now j cap, write j cap, this one. Delta f1 by delta z minus delta f3 by delta x, j cap, plus this one and this one. Delta f2 by delta x minus delta f1 by delta y, k cap. Proved. Just proved. You compare here, compare this. Proved. We have proved that curl vector equal to this. Easy way to remember. Curl f vector equal to, just put the determinant I cap, j cap, k cap, delta delta x, delta delta y, delta delta z. It will be f1, f2, f3. f1, f2, f3. I cap, actually indeterminate, this into this minus this into this. You should put delta f3 by delta y minus delta f2 by delta z I cap plus this into this minus this into this modulo means delta f1 by delta z minus delta f3 by delta x j cap plus finally delta f2 by delta x minus delta f1 by delta y k cap. Thus compare again, same thing has come. Easy way to remember. Now I am going to give you one definition. Irrotational vector. Irrotational vector. A vector is said to be irrotational if curl of f vector equal to zero vector. If curl of f vector equal to zero vector. If curl of f vector equal to zero vector, then it will be irrotational vector. Irrotational vector. Now let me give you another definition. Laplacian operator. Laplacian operator. Nabla dot nabla equal to this Laplacian operator. This is called, it is scalar quantity, is called Laplacian operator. And is defined as nabla square. This equivalent and is defined as this. It is called Laplacian operator. Let f be a scalar point function. Let f be a scalar point function. Then nabla square phi equal to delta square f by delta x square f by delta z square. It should be noted that this nabla square phi is a scalar quantity. Let f vector be a vector point function. Then this nabla square f vector will be equal to delta square will be equal to like this. Delta y square plus delta square f vector by delta z square. It should be noted that nabla square f vector is a vector quantity. It should be noted that this is a vector quantity. Now Laplace's equation. In this connection, I am giving you another, that is Laplace's equation. The equation, this nabla square f equal to 0 is called the Laplace's equation. A function which satisfies Laplace's equation which satisfies Laplace's equation is called a harmonic function. Now you see, we have defined the Laplacian operator, we have defined Laplace's equation, also we have defined the harmonic function. A function which satisfies Laplace's equation is called a harmonic function. It's called a harmonic function. Now, suppose one question is R vector equal to, you know it, xi cap plus yj cap plus zk cap. Zk cap. Divergence of R vector will be equal to 3 and curl of R vector will be equal to 0 vector. When you write divergence, it will be a scalar function, a scalar quantity. When you find the curl of a vector function, it should be written 0 vector, because curl of a vector function is a vector function. Curl of a vector function is a vector. Now, divergence of R vector equal to I cap dot delta R vector by delta x, j cap dot delta R vector by delta y plus k cap dot delta R vector by delta z. Delta R vector by delta z. Now, delta x of R vector, del x of x I cap plus y j cap plus z k cap. K cap. This is equal to, with respect to x differentiation partially, this will be 0, this will be 0, it will be again, it will be simply I cap. Delta R vector by delta y will be equal to delta y of x I cap plus y j cap plus z k cap. You are differentiating partially with respect to y, it will be equal to j cap. And delta R vector by delta z will be equal to delta z of x I cap plus y j cap plus z k cap. It will be equal to k cap. It will be equal to k cap. Therefore, divergence of R vector will be equal to I cap dot I cap plus j cap dot j cap plus k cap dot k cap. It will be 1 plus 1 plus 1 equal to 3. Divergence of R vector is equal to 3. We have found that the divergence of R vector is equal to 3. R vector equal to 3. Now I am going to find the curl of R vector. Curl of R vector equal to I cap, j cap, k cap. You should write here delta x, delta y, del z, and it should be x, y, z. This is equal to delta z by delta y minus delta y by delta z, I cap plus delta x by delta z minus delta z by delta x, j cap plus also delta y by delta x minus delta x by delta y, k cap. This is equal to 0 I cap plus 0 j cap plus 0 k cap should be equal to 0 vector. Should be equal to 0 vector. 0 vector. We have defined divergence of a vector function and curl of a vector function. Now we shall try to solve some simple problems connecting with divergence and curl. Divergence and curl. Let me write the questions in this side and I will answer in this side. Let us try to solve these simple problems. Number 1. First, f vector is given in this form. Divergence of f vector. F vector solution number one. Solution number one. F vector equal to x square y I cap minus twice x z j cap plus twice y z k cap. Therefore, divergence of F vector equal to delta x of, if V vector is equal to V1 I cap plus V2 j cap plus V3 k cap, then let me switch on the another way. See the sound will come. F vector is equal to delta x of x square y. If V vector is equal to V1 I cap plus V2 j cap plus V3 k cap, then divergence of V vector is equal to delta V1 by delta x plus delta V2 by delta y plus delta V3 by delta, like this. You will minus twice xz plus delta z of twice yz. This is equal to, it will be twice xy, it will be 0, plus with respect to z, it will be twice y, and it will be 2 times of x plus 1 into y. Am I right? Twice xy, it will be 0, and it will be twice y again. Twice y, come on, x plus 1. Now number 1, we have done number 1. Curl of F vector. Curl F vector will be equal to I cap, j cap, k cap, delta x, del y, del z, and it will be x square y minus twice xz and twice yz. Twice yz. This is equal to delta y of twice yz minus delta z of minus twice xz I cap. It will be this plus delta z of x square y minus delta x of this one twice yz j cap plus delta x of minus twice xz minus delta y of x square y k cap. This is equal to, it will be twice z minus plus it will be twice z plus, it will be with respect to z differentiation twice x I cap, and with respect to z it will be 0 minus 0 j cap plus it will be minus twice z twice xz minus twice z minus x square minus twice z minus x square k cap, and this final result will be equal to 2 times of z plus h I cap minus x square plus twice z k cap. The answer is this. I cap and k cap. For z cap it will be 0. Now curl number 3. Curl F vector equal to I cap, j cap, k cap, del x, del y, del z. It will be 2 times of z plus 2 times of x. It is 0 minus x square minus twice z. You may write in this way. This is equal to delta y of minus x square minus twice z minus delta z of 0 I cap plus delta z of twice z plus twice x minus delta delta x of minus x square minus twice z cap plus delta delta x of 0 minus delta delta y of twice z plus twice x k cap. It will be like this. And I am writing here. Now, it will be like this. What will be this? 0 minus 0 a cap. This is equal to 0 minus 0 I cap. It will be plus 2 minus twice x z cap. It will be 0 minus 0 k cap. Ultimately, you will get 2 into 1 plus x z cap. Answer will be equal to 2 into 1 plus x z cap. 2 into 1 plus x z cap. Water. We have put number 1. 1 has been done. We have done this one. Because therefore I may remove this one. Now number 2. Simple. Number 2. Number f vector equal to this divergence of vector equal to number 2 x square y I cap plus x y cube z cap. Divergence of f vector equal to delta delta x of x square y plus delta delta y of x y cube plus delta delta z of 0. It will be 0 plus 0 z cap, 0 k cap, 0 k cap. This is equal to twice xy plus thrice xy square. This is the answer. You see, divergence is equal to a scalar quantity, and the z vector equal to x I cap plus y cube z square z cap plus x z cube k cap. Therefore, divergence of z vector will be equal to delta delta x of x plus delta delta y of y cube z square plus delta delta z of x z cube delta delta z. This is equal to 1 plus thrice y square z square plus thrice x z square. This is the answer. Simple. Just differentiate partially. Simple. We have done this one also. Let me check. It is twice xy, thrice xy square. It is right. And 1 plus thrice y square z square plus thrice x z square. Yes, it is. We have done number 2 also. We have solved number 2 has also been done. Now come to number 3. Come to number 3. Now f vector equal to x square yz I cap plus x y square z z cap plus x y z square k cap. Therefore, curve f vector equal to, just write it in the determinant form. Very easy, determinant form. And you write here x square yz x y square z x y z square x y z square. x y square z x square y z. This is equal to delta delta y of x y z square minus delta delta z of x y square z I cap plus delta delta z of x square y z minus delta delta x of x y z square z cap plus delta delta x of x y square z minus delta delta y of x square y z. Okay. This is equal to, I am writing in this side. This is equal to, with respect to y differentiate partially xz square minus xy square I cap plus with respect to z x square y minus with respect to x y z square z cap plus with respect to x y square z minus with respect to y x square z. This is equal to x z square minus y square I cap plus y x square minus z square z cap plus z y square minus x square k cap. This put. This is the answer. Curl of a factor function is a factor function. It will come in factor. Now we have done this curl F. Now curl z vector. Now z vector. Let me write here. Z vector equal to x cos y I cap plus x y square z cap plus 0 into k cap. 0 into k cap. Curl of z vector equal to I cap I should write here x cos y x y square, and it is 0. It is 0, and it will be equal to delta delta y of 0 minus delta delta z of x y square I cap plus delta delta z of x cos y minus delta delta x of again 0 z cap plus delta delta x of x y square minus del del y of x cos y k cap. It will be like this. This is equal to 0 minus 0 I cap. It will be again 0. 0 minus 0 z cap plus differentiate partially with respect to x. It will be y square. Y square. X constant. If you differentiate partially with respect to y, x constant, and cos y, differentiation of cos y is minus sin y. Minus minus will be equal to plus. X sin y. X sin y. K cap. This is equal to y square plus x sin y k cap. X sin y k cap. Answer is this. This is the answer. We have done number 3 also. We have done number 3. So see what is going to this. Now come to the final answer. Look at final question. Question number 4. F vector be a constant vector field. Divergence of F vector is 0 and curl of F vector is also a 0 vector. Divergence of F vector is equal to 0 vector. Curl of F vector is also a 0 vector. Now f vector is a constant vector. F vector is a constant vector. F vector is a constant vector. Let F vector equal to A1 AI cap plus BJ cap plus CK cap. ABC are constant scalars. ABC are constant scalars. Therefore, divergence of F vector equal to delta A by delta X, delta B by delta Y, delta C by delta Z will be equal to 0 plus 0 plus 0 will be equal to 0. Simple. 0 plus 0 equal to 0. Curl of F vector. Now, let me write in this side. Curl of F vector. Curl of F vector equal to I cap, J cap, K cap, del del X, del del Y, del del Z. ABC, you may write ABC. This is equal to delta C by delta Y minus delta B by delta Z. I cap plus delta A by delta Z minus delta C by delta X J cap plus delta B by delta X minus delta A by delta Y K cap. This is equal to 0 minus 0 I cap plus 0 minus 0 J cap plus 0 minus 0 K cap. You may write 0 I cap, 0 J cap, 0 K cap equal to 0 vector. Curl of F vector equal to 0 vector. Thus all the problems have been solved. Let us take some more simple problems. Let us try to solve this problem. Very easy. Determine the constant A. So that the vector B vector is given. Is solenoidal. We have to find the divergence of B vector. The divergence of B vector should be equal to 0. Not 0 vector, 0. Should be equal to 0. The vector number 1. Solution number 1. The vector B vector is solenoidal. If divergence of B vector equal to 0. This means delta X of it should be X plus thrice Y plus delta Y of Y minus twice Z plus delta Z of X plus AZ should be equal to 0. Since B vector equal to this. B vector, the vector equal to, you may write like this also. You may write here also. X plus thrice Y I cap plus Y plus minus twice Z. Y minus twice Z J cap plus X plus AZ K cap. This means it should be 1 plus 0. 1 plus 0 plus 1 minus 0 plus 0 plus A should be equal to 0. This means 1 plus 1, 2 plus A equal to 0. This means A equal to minus 2. Answer A is equal to minus 2. A should be equal to minus 2. The vector B vector should be solenoidal. If divergence of B vector equal to 0, divergence of B vector equal to 0 means A is equal to minus 2. Answer A is equal to minus 2. We have done this number 1. Number 2, come to number 2. So that the vector Iman is irrotational. A vector B vector will be irrotational if curl of B vector should be equal to 0. Curl of B vector should be equal to 0. Come to number 2. Number 2. The vector B vector equal to sin Y plus Z I cap plus X cos y minus z cap plus x minus y k cap is irrotational if curl of f vector should be equal to 0 vector. Curl of f vector equal to 0 vector. Now I am going to find curl of f vector. Thus, now curl of f vector equal to I cap, j cap, k cap, delta delta h, del del y, del del z. It should be your sin y plus z, x cos y minus z, x minus y, x minus y. We have to show that curl f vector equal to 0. Then then p vector will be irrotational. This is equal to delta delta y of x minus y minus delta delta z of x cos y minus z I cap plus delta delta z of sin y plus z minus delta delta x of x minus y z cap plus delta delta x of x cos y minus z minus del del y of sin y plus z, sin y plus z k cap. Now find it will be equal to minus 1, 0 minus 1, and it will be equal to minus 0 minus 1. And I cap, and it will be 0 plus 1 minus 1 minus 0 j cap, and it will be cos y minus 0 minus again cos y plus 0 k cap. It will be like this. After that I am writing here. I am writing here. Minus 1 plus 1 I cap equal to 0. 0 I cap plus 1 minus 1 j cap 0 j cap plus cos y minus cos y equal to 0. K cap equal to 0 vector. Since curl of v vector equal to 0 vector, therefore the vector v vector is irrotational. V vector is irrotational. Now number 3. Come to number 3. Come to number 3. I am number 3. Number 3. A vector is a constant vector. A vector is a constant vector. Let A vector equal to A1 I cap, A2 j cap plus A3 k cap. A vector is a constant vector, therefore let this one equal to this. Also, R vector equal to X I cap plus Y j cap plus Z k cap. R vector is equal to this. Therefore, you are to find first R vector cross A vector. Therefore, R vector cross A vector equal to I cap, j cap, k cap. It will be X, Y, Z, A1, A2, A3. A1, A2, A3. A1 into A3. This is equal to this into this minus this into this. A3y minus A2z I cap plus A1z minus A3x j cap plus A2x minus A1y k cap. R vector this will be this. Therefore, divergence of R vector cross A vector will be equal to delta x of this one A3y minus A2z A2z plus delta y of A1z minus A3x plus delta z of A2x minus A1y. A1y. It will be, you are differentiating partially with respect to x. No x is there. Therefore, it will be 0. You are differentiating partially with respect to y here. No y is there. It will be 0. Also, this will be equal to also 0. This is equal to 0 plus 0 plus 0. This is equal to 0 plus 0 plus 0 equal to 0. Therefore, divergence of R vector cross A vector equal to 0. Right? I cap delta x of this, yes, it will be 0. Now, curl of R vector cross A vector. Curl of R vector cross A vector equal to I cap, j cap, k cap, delta x, del y, del z. And it will be R vector cross A vector. You will have to write this one. A3 y minus A3y minus A2z. A1z minus A3x. And it will be A2x minus A1y. A2x minus A1y. A1y. Curl of R vector cross A vector equal to this. Just use the blue plane delta y of A2x minus A1y minus delta z of A1z minus A3x I cap plus delta z of A3y minus A2z minus delta x of A2x minus A1y j cap. A1y j cap. A1y j cap. Plus delta x of this one A1z minus A3x minus delta y of A3y minus A2z k cap. Now, what will be this? This is equal to 0 minus A1 minus A1. It will be minus A1. It will be 0. It will be minus A1. With respect to Z, again minus A1. I cap plus it will be with respect to z minus a2 minus again a2 z cap plus it will be with respect to x minus a3 again with respect to y minus a3 k cap. This is equal to minus twice a1 I cap minus twice a2 j cap minus twice a3 k cap. This is equal to minus 2 a1 I cap plus a2 j cap plus a3 k cap. You will get this one. This is equal to minus 2 times of a vector. Curl of r vector cross a vector equal to minus 2 times of a vector. Since a vector is equal to a1 I cap plus a2 j cap plus a3 k cap. This last one also have been also has been solved. Now come to the number 4. Number 4. We have to find curl v vector when v vector is equal to this. V vector is equal to this. I have seen that. V vector is equal to e to the power xyz I cap plus e to the power xyz z cap plus e to the power xyz k cap. It is given. V vector is equal to this. I cap z cap e to the power xyz common I cap plus z cap is this. Therefore, curl of V vector equal to I cap, j cap, k cap, delta delta x, del del y, del del z. It will be e to the power xyz, e to the power xyz, also e to the power xyz, the determinant of this. This is equal to, from this will be equal to delta delta y of e to the power xyz minus delta delta z of e to the power xyz I cap plus delta delta z of e to the power xyz minus delta delta x of e to the power xyz, it is z cap plus delta delta x of e to the power xyz minus delta delta y of e to the power xyz k cap. This is equal to, with respect to y, e to the power xyz xz e to the power xyz xz minus e to the power xyz with respect to z xy I cap plus e to the power xyz xy minus e to the power xyz yz z cap plus e to the power xyz yz minus e to the power xyz with respect to y xz or zx k cap. Right? Curl of v vector equal to this. Curl v vector will be equal to this. Now, what will be this? E to the power xyz zx minus xy I cap plus e to the power xyz xy minus yz z cap plus e to the power xyz yz minus zx k cap. 0 bar xyz this is the answer. This is the answer. Therefore, curl of the vector v vector will be equal to this. Zx minus xy I cap plus 1. Perhaps you have found that divergence and curl of vector functions are very easy. I hope you have enjoyed the class. We shall meet in the next class. I want to stop here. Thanks for attending the class. Thank you very much. Thank you.